Okay, this is the last video for section 5.2, and in this video we're going to look at dividing radical expressions. The preamble in your book, much like when they did multiplication, is a little bit of a mess, but basically if you have a mixed radical, so a coefficient and a radical, divided by another mixed radical, a coefficient and another radical, and the radicals have the same index, in this case k, to divide, we can divide the coefficients and treat that as one quotient, and we can bring the two radicands together under the radical sign with the same index. Okay, so k is a natural number for our index. M, n, and a and b are real numbers. Because we're dividing by n and dividing by the root of b, neither of those can be 0. And if k is even, our restriction is that the radicands are not allowed to be negative. So a must be greater than or equal to 0, and b must be greater than 0. And the only reason b is not greater than or equal to is because it's in the denominator here. Okay, so with that out of the way, let's take a look at how this works in practice, which is actually much simpler, I think. So it says simplify each expression. In the first one, we have the square root of 24x squared divided by the square root of 3x, and we are told x is greater than 0. So again, because we have an x in the numerator, it can't be 0, or the denominator, it can't be 0. And they're both under the same square root with the same radical with an index of 2. So in this case, we just put them together under the square root, and we go 24 over 3 and x squared. Well, 24x squared over 3x, all under the square root. 24 divided by 3 is 8, and x squared divided by x is x. So this is the square root of 8x. We can do a little bit more simplifying with that. We can think of 8 as 4 times 2. So this is the square root of 8x, or the square root of 4 times 2 times x. I can pull out the square root of 4 because that's a perfect square, which would be 2. So it's going to be 2 root 2x. And again, because of our earlier restriction from the beginning, x is not allowed to be negative. Yeah. Okay. First one, not too bad. Everything divided out nicely. Second one, it's still not going to be too bad, but it's not as neat as this one, right? You see 4 divided by 3, and it's like, okay, well, that's 4/3. And then we see root 5n divided by root 2. Well, that would be the square root of 5n over 2 if you think about it the way we did this one. And n is not allowed to be negative because it's a variable underneath a radical with an even index. Right, so really to divide this, all we're going to do is rationalize the denominator like we did in the previous video. So I'm going to take my 4 root 5n divided by, it's a very ugly 4, I think I can do a bit better. Okay, 4 root 5n divided by 3 root 2, and I'm going to rationalize this denominator. So to get rid of a root 2 on the bottom, I'm going to multiply the bottom by the square root of 2. And if I do that to keep this equivalent, I've got to multiply the top by the square root of 2. And this should do it. There might be some simplifying in the end, but there's not a lot more to this one. Okay, so on top, 4 times root 5n times 2, I can put those together. That's going to be 4 times the square root of 10n, right? Because 2 times 5n under the radical sign is going to be 10n. And on the bottom, 3 times root 2 is going to be 3 times, so it's the square root of 2 times 2, the square root of 4. And the square root of 4 is just 2. Right, or root 2 squared, and you might have just jumped to 2 here anyway. So this is going to be 4 root 10n divided by 3 times 2. You can do one of two things here. You can divide the 4 and the 2 and put it in simplest form right away, or I'll do it the long way first. We can go 4 root 10n divided by 6. And then 4 over 6 will simplify. Those are both divisible by 2 to 2 root 10n divided by 3. Okay? And again, you could have gone there directly here if you'd wanted to by dividing 4 by 2, which would have made the numerator 2, or the long way. Whichever works for you is fine with me, but they'll both get you to your most simplified form. Okay, so those weren't so bad, and I'm only 5 minutes in. So let's take a look at a couple that have the potential to not be quite so nice. Okay, so here are our last two. This one, the very, very last one has a cube root in it, so that's going to be a different kind of fun, which is why we save it for last. And this one has a binomial on the bottom. So if we just started to think of this as a division, it's really, there's not a lot I can do to divide this. So what I'm going to do is rationalize my denominator. So I got to multiply top and bottom by the conjugate of root 5 plus 7. So I'm going to take 11 over root 5 plus 7. I'm going to start with some brackets there, and I'm going to multiply by the conjugate over the conjugate of root 5 plus 7. And the conjugate, remember, is the thing you'd multiply by to make a difference of squares. So if this is root 5 plus 7, my conjugate is root 5 minus 7. And I multiply by root 5 minus 7 over root 5 minus 7 because this is just a special way to write 1, and all I'm doing is scaling my expression by 1, which is not going to change anything. It's going to give me an equivalent expression. Numerator will not be too bad. I have 11 times root 5, which is 11 root 5. And then 11 times minus 7 is minus 77. And on the bottom, I've got my difference of squares. So root 5, it's going to be root 5 times root 5 will be the first term. And that's just going to be root 5 squared, otherwise known as 5. My cross terms, root 5 times minus 7 and 7 times root 5 will go away, so I'm not going to bother with those. And then on the end, I'm going to have minus 7 squared, which is 49. Okay, and then we have 11 root 5 minus 77, all divided by 5 minus 49 is negative 44. Okay. And as you might have guessed, if you see the 11, the 44, and the 77, there's going to be some simplifying that we can do involving the number 11. And because the bottom is negative, the simplest thing to do, I think, is factor out a negative 11 from each one. So if I factor out a negative 11 on top, I'm going to get negative root 5 plus 7. And if I factor out a negative 11 on the bottom, I'm going to get negative 11 times 4. Okay, negative 11 divided by negative 11 equals 1. So those effectively go away. And I am left with minus root 5 plus 7, all divided by 4. Or if you like, 7 minus root 5, all divided by 4, if it offends you to have that minus sign in front on the root 5. Okay? Those are going to be equivalent expressions, and both would be fine as the final simplified form. All right. Last but not least, we've got this thing with this thing. We've got a cube root of 6 on the bottom. Now, y can't equal 0 because we're dividing by y, so that's just our restriction based on the fact that we can't divide by 0. But we've got to get rid of this cube root of 6. So what we need to do to rationalize this denominator is turn the denominator into something that is cube rootable, if that makes sense. That is a perfect cube. So what we're going to do is we are going to start with our 4. That's not a 4. We're going to start with our 4 root 11. And now we're going to look at our bottom, y times the cube root of 6. And to get this cube root, the simplest way to get this cube root into something I can perfectly cube root and make into a rational number is to have 6 cubed in there, right? So remember, when it comes to our roots, that if I have 6 cubed and I cube root 6 cubed, that just gives me 6. So the cube root of 6 cubed is 6. So I've got to multiply top and bottom by something that's going to turn this into the cube root of 6 cubed. And that turns out to be the cube root of 6 squared, or the cube root of 6 times itself. Okay, so our thing we're going to multiply by is going to be the cube root of 6, not the 6th root of 6. The cube root of 6 times the cube root of 6. And then on the bottom, cube root of 6 times the cube root of 6. Okay? And this is really all about rationalizing the denominator. It's going to make a mess of the numerator, but that is okay. So when we do our numerator, remember, this is a square root, this is a cube root. I can't bring those together under the radical sign. So I'm going to have my 4, I'm going to have my square root of 11, and I'm going to have the cube root of 6 times the cube root of 6, which now those I can put together, and that will be the cube root of 36. Okay, that's my numerator for the moment. There might be some simplifying later, but for the moment, that's it. On the bottom, I'm going to have y times the cube root of 6 times the cube root of 6 times the cube root of 6. So that is the cube root of 6 times 6 times 6, or 6 cubed. So this gives me 4 square root of 11 cube root of 36, all divided by the cube root of 6 is 6, so I'm going to flip that out front and call that 6y. Okay. When you're looking at simplifying from here, start with the square root. 11's a prime number. I can't do anything to simplify the square root of 11 further. 36 and cube roots, you might think you can do something with that. If you think about your cube numbers, though, remember 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and then 4 cubed would be 64. And 8 might be tempting to look at, but 36 is not evenly divisible by 8. Not evenly. It'll divide nicely. You'll get a decimal that's not so bad, but it can't be divided evenly. And 27 is right out. So this cube root of 36 will also not simplify. The y is on the bottom, and that's okay because it's not a radical. The only thing that we can simplify now is the 4 over 6. So 4 and 6 are both divisible by 2. So our simplest form for this guy, 4 divided by 2 is 2. So I'm going to have 2 root 11 cube root 36, and 6 divided by 2 is 3. So this is actually as good as it gets for D, and I didn't put a box around this one, so I don't want it to feel left out. Yeah, and that is some radical division. I'm never going to get tired of that joke. Anyway, thank you for watching. I hope you will find this useful.